Hello, hello. Just check. Voice is audible. Screen is visible.
Yes, sir.
Yes, sir.
Yes, sir.
Very good morning to all. This is our first lecture of the day. Let's hope we will continue with enthusiasm. Last lecture, what we have seen, just a review. Those still students will join. What we have seen last lecture, angular motion. Is it correct? Just we have compared angular motion with linear motion and how so equations of angular motion we have seen. Okay. To understand what is angular motion, just we have compared angular motion with linear motion because with the help of comparison only we can study what is angular motion. Is it correct? Uh, Terminology we can see. Even we have discussed in case of linear motion, yes, displacement theta. In case of angular motion, which is in radian, that we have seen initial velocity u, omega 0, final velocity v, here omega, acceleration a, here alpha t, and this. So basic equation we know, s is equal to vt. So that same equation we have drawn here. Theta is equal to omega into t. What the way we have compared or we have converted kilometer per hour into meter per second. Similarly, here also, when angular velocity is given in terms of revolution per minute, it is necessary to find or necessary to convert it into radian per second. That also we have discussed how we can convert it into radian per second. So one complete revolution is nothing but 2 pi, and one in 1 minute, how many seconds are there? 60. So that multiplication factor we got 2 pi upon 60. And these equations we solved. It is very simple. By just comparison, you can remember. So directly, it may not be possible to remember, but by comparison, you can remember this. So this we have seen. Okay. And problems we have solved. Thereafter, we have solved the problems. I think it is there with you right now. Already we have solved. After that, just we have started this projectile motion. Okay. And we have discussed what is projectile motion. There are certain different types of projectile motion. What is projectile motion? It is a combination of two things. Which are they? We have seen it is a combination of horizontal motion and vertical motion. So, are you remembering this sentence we have seen on that day, or maybe in last lecture? What is projectile motion? It is nothing but combination of vertical motion and horizontal motion. Means if you throw any object in the air from the ground, suppose it may have combination of horizontal axis till it will reach highest point, it will go vertical, maybe in vertical direction, not exactly but vertical. Then it will fall on the ground by taking horizontal movement of horizontal direction. Or that's why we are calling projectile motion is a combination of horizontal and vertical motion. After that, we have seen different terminologies in projectile motion. Which are they? One is trajectory. What is trajectory? It is path traced by the object. Then projectile, we have seen what is projectile: object, time of flight, maximum height up to where it will reach, then a range of flight, then initial velocity, with what velocity we are going to throw the object, then initial angle, either we can say theta or whatever. Okay. Further, are you with me? Those who are online.
Yes, sir.
Yes, sir.
This bit just we have started projectile
Sir.
motion. Actually, there are 3 to 4 types are there. Okay, for this. So, first one is what? So just as a we can say as a basics, we will see there are three four types are there. Suppose types means what? Projectile motion can be converted into four types. First one is in front of you. What is that? If suppose from a ground, suppose from a ground, object is there at certain height h. Object is there at certain height h, and it is thrown from this with initial horizontal velocity. Yeah? That's u, horizontal velocity. This is type number one. I will say. We will see what are the formulas, etc. This is type number one. Uh, from here it is projected, and then it automatically it is going to fall somewhere here. So that we are going to call it as R. So this is type number one. Are you getting? So first type of projectile motion is what? Object is raised through certain height h, and then it is thrown horizontally. Yeah, this word is very important here, horizontally, and it will fall after that. This is type number one. Second type, just I will say which are the types under projectile motion. Second type is what? From the ground level itself. From the ground level itself, the object is thrown. The object is thrown with certain angle, which certain angle which is making with the horizontal and with the initial velocity u, and it is going to fall certain. Make something here. Okay, means here in second case, what is happening? We are just throwing the object from the surface itself with initial velocity u, and making an angle inclined way, can say inclined with ground in that way. This is second type of projectile motion. Third type is what? So from the ground itself, object is thrown. Okay, maybe here from this point, object is thrown from the ground, maybe something with the velocity of again u, velocity of u, and here angle is theta in this way. Provided that we are not waiting that object should fall on the ground. So here that object is taken on maybe somewhere here, inclined the plane. Here there is an inclined plane, I will say. The object is going to touch the earth on inclined plane. Means suppose I will give maybe little. Maybe here from somewhere here object is thrown with the velocity of u and here theta. So once it is going to fall, so it is there we are going to collect on inclined plane. Whatever object is going to take, we are going to see on it inclined plane. This is third one. Just remember what are the types of fourth one is what? Here it is similar to first one, similar to something similar to first one. Object is raised to certain height. Object is raised to certain height. Okay, and thereafter, from here object is thrown. From here object is thrown with certain velocity u, which is inclined to horizontal again, which is inclined to horizontal. And while collecting the object, once it is going to strike to the earth, that object may be somewhere. It is not going to come something like on the, we can say, ground. So, but we are going to take it on inclined plane. Here we are going to cut on, or we are going to collect the object on inclined plane somewhere like this. So these are the four different types of projectile motion of the object. Okay, maybe here somewhere we are going to take on the inclined plane itself. Okay, here we are going to see. So whatever that parameter. But as far as syllabus is concerned, till today, are you getting which are the different types of projectile motion? First one is simple motion. From the ground, object is raised through height h and thrown horizontally with initial velocity u. Number one, simple type. Second one, from the ground, object is thrown in inclination with angle theta with the horizontal with initial velocity u, and it is going to collect or it is going to strike the earth on same level. Here, in other words, we can say same level. Same level means from where it is thrown, it is going to come at that same level. Simply, in third type, we are going to throw the object from the ground level, but it is not going to come on the same level. It is going to be on something height. That is, we are going to call it as inclined plane. And in fourth case, object we are going to throw from certain height, maybe height h, but it is not going to strike to the ground, but somewhere else. So these two types are not there in the syllabus. Just for your information, I have told. So this first one and second one we are going to study. This it is for your information. Third and fourth, just for information, but first and second it is there in the syllabus that we should know how it is. Okay, are you with me? Projectile motion. So projectile motion itself is a very large concept, we can say, very big concept. Just I have given introduction how different four types of projectile motions are there. Okay, out of that, first two we are going to see. Third and fourth, it is not a part of syllabus. Third and fourth, just we can remember many more derivations, many more terminology will be there in the syllabus. Okay, coming back to projectile motion number one. So object is raised through certain height h, and it is thrown with the certain velocity, initial velocity u. So here two formulas we have to remember. So here which are they? How it is? So that also we will see. So only two formulas are there for case number one. Object is raised through certain height h and it is thrown with initial velocity horizontally. That word is most important. This once it is thrown horizontally, only two formulas are there. So how that formulas came? For that, our linear equation motion u is equal to ut plus 1 half at square. This equation is used. U is equal to ut plus 1 half at square. And from this equation, two things we have to find. Number one, time of flight. Time of flight. And number two, range. So here it is there, range. Horizontal range, R. Only these two things will be asked. Only these two things will be asked for projectile motion number one. Only these two formulas. How it is? How that formula is came for projectile motion number one. So if you will put once object is going to raise from here up to here h. Okay, so just it is raised and suppose released. Simply it is raised and released. So with the initial velocity 0. With the initial velocity. So here there is no question of 0. Or if it is thrown, it will go little depth. So in the first equation, value of u is kept 0. So you may think that if at all we are going to throw the object with initial velocity u, why we should keep u is equal to 0? So answer is what? Answer is what? Here once we are going to throw the object, it will have vertical motion like this. It is told. It will have vertical motion. Okay, but how we have thrown the object? Horizontally. So horizontal component of this initial velocity, while considering vertical motion, what will be that? काय म्हणतोय बघा मी. Here we are going to consider vertical motion, but how we have thrown the object horizontally. What will be the vertical component of that initial velocity while considering horizontal motion? Sorry, while considering vertical motion, 0. Once we are going to put here u is equal to 0, we will get time of flight. Or you can remember value of s will become h, and once this u will become 0, this term will become 0, and this 1 half. How object is going to fall? Along the gravitational force or opposite to gravitational force? Along the gravitational force. Then value of acceleration will be become positive or negative? Positive. So it will be simply gt square. So this will be the formula to find out time of flight. This will be the formula for finding out time of flight. Simply, if you are knowing how it will come, otherwise you can remember simply h is equal to 1 half gt square. From this, what is h in this formula? H is the height through which that object is raised. H. What is t? T is the time taken by object to reach up to the ground. That is time of flight. In other words, we can say time of flight. Okay. Next one is range. How we have found range? So here one more assumption is here. Once we are going to throw the object, its velocity is not going to change. While it is going to touch to the ground, it is traveling with uniform velocity. Like this it is told. Means once we are going to throw the object horizontally, while reaching to the ground, it will travel with uniform velocity. If it will travel with uniform velocity, what will be the its effect on acceleration? Acceleration किती होईल त्याचं? Uniform velocity जर असेल तर acceleration किती असेल? Change in velocity is 0. What will be acceleration? 0. So while finding this range, horizontal range, yes, instead of yes, now I will write h. Sorry, instead of yes, r. So if this term will become 0, the term 0 will. Ka 0 will? Uniform acceleration. So it will give ut. So these two formulas only we have to remember. या केस मध्ये केस नंबर 1 मध्ये दोनच फॉर्म्युला लक्षात ठेवायचे आहेत. कुठले? h is equal to 1 half gt square and r is equal to ut. What this equation will give? इक्वेशन वरून काय मिळते आपल्याला? जर हाईट माहित असेल तर काय मिळतोय? टाइम. पण तो कसला टाइम म्हणणार? व्हॉट इज द काइंड ऑफ टाइम? Time of flight means the time taken by the object to reach up to the ground. And what is this? R is equal to, R stands for what? Range. R stands for range. Okay. E is equal to ut. If we know initial velocity with which object is projected horizontally, most important word, horizontally. Okay. So R is equal to ut, where t is time of flight. आलं का लक्षात? सगळं जरी काय लक्षात नाही ठेवलं तरी चालतं. एवढे दोन दोन फॉर्म्युला लक्षात. हॉरिझॉन्टल मोशन साठी कुठले दोन फॉर्म्युला आहेत? व एक पहिला कुठला? h इज इक्वल टू 1 हाफ gt स्क्वेअर आणि सेकंड वन इज r इज इक्वल टू ut. आलं का लक्षात? एवढे दोनच फॉर्म्युला लक्षात ठेवायचे पहिल्या केस साठी. ओके, आलं का लक्षात? बाकी काय लक्षात? युनिफॉर्म वेलोसिटी वगैरे वगैरे, फॉरगेट अबाउट दिस. You can remember these two formulae and you can write in your notebook. We will solve one or two problems on this. Okay, are you with me online? Those who are online.
Yes, sir.
Yes, sir.
Yes,
Yes,
sir.
sir.
Very good. So just write down two formulas for case number 1. Once object is projected horizontally, only two formulas. Number 1, time of flight. h is equal to 1 half gt square. So from that you can find formula for time. So what it will become? जर तुम्ही सिम्प्लिफिकेशन केलं तर काय होईल होतो? अंडर रूट 2 gh t is equal to, it will go for simplification. Simplification काय होईल t साठी? For what it will be? For root of 2
2h
g will become to denominator. Very good. 2h by g, you can write that as well. So h is equal to 1 half gt square. So you can get the formula. Only two formula. And what is the horizontal range? How much object will go horizontally if we have thrown the object from certain height having initial velocity u? किती असेल त्याची range? ut. It will be ut. Correct? Are you with me? समजतंय का काय चाललंय? Only two formulas we have to write, nothing else. We will solve one or two problem, then we will see how it is. Shall we go next? I have written two formulas. H is equal to 1 half gt square, r is equal to ut. Simple. Shall we go next? Problem
Yes,
number
sir.
1. Problem number 1 from this. Let us see what is that. A pilot flying his bomber at a height 2000 meter with uniform velocity. With uniform horizontal velocity of 600 km per hour, wants to strike a target. At what distance from the target he should release the bomb? Problem is something like related to bomber. So you can remember our currently issue, which current issue is going on right now? Russia and Ukraine, no? How they are launching the bomb, etc. So what is bomber? Bomber means what? Anybody knows meaning of bomber? कशासाठी? एक पायलट आहे, ही इज फ्लाइंग हिज बॉम्बर. पायलट काय करतो? काय चालवतो? रिक्षा चालवतो का? एरोप्लेन. Actually, bomber is one of the type of aeroplane which is specially used for to launch bomb. बॉम्ब टाकण्यासाठीच असते ते विमान खास. It is called as
Yes,
bomber.
sir. To carry and drop bomb.
To carry and drop the bomb, we can say. So you might be observing on the television as well. Okay, Ukraine, which one? Ukraine and Russia. Something like that. Forget about Ukraine and Russia. Pilot is flying his bomber, means aeroplane, at a height. Height माहिती आपल्याला किती height वर आहे, with uniform horizontal. This word is most important in this problem. With horizontal velocity of 600 km per hour, and he wanted to strike the target. He want to strike a, means what? If you'll draw maybe something diagram. Okay, simple. We don't know range. Maybe suppose here there is target T. I will say here target. Okay, and here it is a let us say here it is maybe 200 meter. Okay, H, and here it is. From here he want to target maybe something very simple. It will apply the mind. Height is known to us from where, even initial velocity is also known to us. Okay, from here he is going with certain velocity. Okay, u, and he want to go for maybe target something like this. So we know u, how much it is given, or h is equal to how much? 2000 meter. Initial velocity u कितीने चालू आहे एरोप्लेन सध्या? Velocity 600 kilometer per hour. Is it necessary to convert this? In which unit we should convert, because height is given in meter and velocity is given in kilometer per hour. How to convert? Which will be our multiplication factor? किलोमीटर आवरचं मीटर पर सेकंड मध्ये करायचं. मग कसं ना, 18/5 or 5/18? हा, 5/18. 5/18. किती येते सांगा हे? Meter per second. It will be meter per second. So tell me how much it is. सांगा. Calculator. Open the calculator and tell me calculation. किती आलं? U is equal to 1.
166.66.
1 6.
6.
6.
0.66.
0.66 meter per second. Is it correct?
Yes, sir.
Yes,
Correct?
sir.
Okay. Next. Anything else is given? Nothing is given. Now simply now, for projectile motion, काय म्हणू आपण, for object projected horizontally असं म्हणायला पाहिजे, or for projectile projected horizontally असं म्हणू शकतो आपण. प्रोजेक्टाइल म्हणजे ऑब्जेक्ट ना. प्रोजेक्टाइल प्रोजेक्टेड हॉरिझॉन्टली. वी नो टू फॉर्म्युले. विच आर दे? आपल्याला दोन फॉर्म्युले माहित आहेत. कुठले? स्पेलिंग बघा, नंतर तुम्ही तो काढताल स्पेलिंग. हॉरिझॉन्टली TALY का TALLY काय असतं इथं? इंग्लिश इंग्लिश एक्सपर्ट कोण आहे आपल्यात? कुठले दोन फॉर्म्युला माहित आहेत आपल्याला? H इज इक्वल टू काय सांगितलं मगाशी 1/2
into
GT स्क्वेअर.
GT square.
हा, आणि पुढचा कुठला सांगितला? R इज इक्वल टू
UT.
QT. आपलं एक राहिलं की गिवन झालं टू फाइंड रेंज. आपल्याला रेंज फाइंड आउट करायचे. टू फाइंड रेंज R इज इक्वल टू हाऊ मच? रेंज R इज इक्वल टू हाऊ मच? आणि हे गिवन आहे बरं का, इथं पण लेटर आहे given. ठीक आहे. Now we know the formula R is equal to UT. This R we want to find R. की कुठून बॉम्ब टाकला पाहिजे म्हणजे तो टार्गेट वरती जाऊन पडेल. R माहित काढायचा आहे. फॉर्म्युला also we know R is equal to UT. Can we apply this formula directly? Why? Can we apply second formula directly? R is equal to UT. U is known to us. Whether we are knowing T,
No, sir.
No, sir.
T is not known to us. Then what we have to do? काय केलं पाहिजे मग? पहिल्यांदा टी फाइंड आउट केला पाहिजे. हाऊ मच दॅट बॉम्ब विल टेक टू रिच अप टू द टार्गेट. टी कसा फाइंड आउट करायचा मग? फर्स्ट इक्वेशन. यू कॅन यूज फर्स्ट इक्वेशन टू फाइंड टी इक्वल टू हाऊ मच. Therefore H is equal to 1/2 GT square. आता याच्यामध्ये काय काय माहिती बघा. Whether you are knowing H, yes, 2000 equal to 1/2 into 9.81 into T square. So from this you tell me value of T. Will you tell or shall I calculate? सांगा. कुठं आहे तुमचं अविनाश? तुमचं कुठं आहे कॅल्क्युलेटर? किती आली व्हॅल्यू टीची?
407.7.
किती? 20 point 20.19. I don't know, or shall I calculate? बरोबर आहे. ऑदर्स ओंकार तुमचं सांगा की त्याला. तेवढंच आहे. अजून पाठीमाग गणेश का काय नाव झालं ते? आकाश, सॉरी. किती आलं? Is it correct? Shall we go next? Next. If you are knowing T now, simple. Range is equal to, very simple. Range is equal to U into T. What is U? 166.66 into calculate this.
336.
Hence, tell me how much?
3364.
3364.
64.86.
0.86. Unit will be what? Meter, no? Hence, bomber should release bomb from distance of किती येत आहे? 3364 म्हणजे 3 किलोमीटर पासून का? 0.86 मीटर. बरोबर आहे ना?
Yes, sir.
Any problem? Simple one, nothing else. Are you with me?
Yes, sir.
So means almost we can say 3364 4 means 3.5 किलोमीटर ना अप्रॉक्सिमेटली. किती मीटरचा 1 किलोमीटर असतो? म्हणजे किती आलाय आपला आन्सर? 3364 मीन्स ऑलमोस्ट 3, म्हणजे विमानातून 3 किलोमीटर वरून बॉम्ब टाकू शकतो तुम्ही. इट मे बी. एनी प्रॉब्लेम? समजतंय का काय चाललंय? आता आपण एक बॉम्ब टाकलेला आहे आता. किती पर्सेंट टाकावं लागेल एक बॉम्ब इथून? 336 कॅल्क्युलेट केले आपण. ओव्हर? इज इट ओव्हर?
Yes, sir.
सिद्धलिंग, रोल नंबर 14. 14.
Yes, sir.
Is it over?
Yes, sir.
Okay. Have you written in the notebook, no?
Screenshot घेतलो सर.
स्क्रीनशॉट ने काय होणार आहे? नोटबुक नाही का तुमच्याकडे? सिद्धलिंग
नंतर लिहितो
notebook,
सर.
notebook. No, rework. It will be rework. Why to go for rework? Otherwise, it will be wastage of time again and again. You can write problem statement, etc. afterwards. Try to, because time is very less, out of time. We can say
Okay, sir.
you are having very. Try to write. Try to take screenshot. Be sincere. Dheeraj 16. 16 roll number. Okay, no issue. Shall we go next? Shall I give one simple problem for you then? One more problem. If it is over, let's go next. Next problem. Simple one again. A person wants to jump over a ditch. Ditch means what? A person wants to jump over a, काय म्हणतात त्याला? What it is? कोण आहे आपल्यात इंग्लिश एक्सपर्ट आपल्याला कोणतरी लागणार आहे. Who is English expert from our class? A person want to jump over a ditch as shown in following figure. Find the maximum velocity with which he should jump. Actually, it should not be maximum. It should be minimum. You can write statement. Afterwards, we will discuss. A person want to jump over a ditch. What is meaning of ditch? As shown in following figure. Actually, it should not be maximum or okay. Okay. Sorry. खंड.
Sir, ते खड्डा
खंड.
टाईप असतं ना.
नाही खड्डा टाईप नाही, खड्डाच असतो तो. कोण म्हणतोय खड्डा टाईप? ऋतुजा?
सर हा.
ओके ओके. खड्डा. डायरेक्टली वी कॅन से खड्डा. नो इश्यू. What is problem? Problem statement is what? One person want to jump over a ditch. As shown in following figure, find the maximum velocity. Actually, I am confusing with this word again, maximum. Why it is called maximum? Huh? It should be minimum, no? Why I don't know why it is given maximum. So, maximum म्हणल्यावर तो असे सगळे खड्डे पार करत जाऊ शकतो ना. I am doubtful with this word. Actually, it should be minimum. It should be minimum. Minimum point. We will check. Because if he will jump with minimum velocity and again less than minimum velocity, he will fall into this. काय प्रॉब्लेम स्टेटमेंट बघा समजून घ्या. एका पर्सनला काय करायचं की तो खड्डा जो आहे त्याच्या पलीकडे उडी मारायची आहे. त्याची काय तर लेंथ दिली आपल्याला. पर्सन मे बी ऍट द पॉइंट ए या ठिकाणी असेल, तिथून त्याला जंप करायचा आहे. velocity. U is not given, initial velocity. Or I will say before that, what will be the value of h in this problem? म्हणजे ग्राउंड लेवल पासून तो पर्सन किती हाईट वरती आहे हो? तेव्हा का इथं आहे ग्राउंड लेवल, इथं ग्राउंड लेवल आहे, तो त्याच्या पण वरती आहे आणि ग्राउंड लेवलचा खाली पण इथं खड्डा आहे आणि त्याच्यामधून जंप करायचा आहे त्याला. इथे एक लक्षात बघा. What will be the value of h in this case?
2 meter.
2 meter.
2 मीटर घ्यावं लागेल आपल्याला. Okay. Anything else is knowing? R is also known. R. Is it known to us? R? 3 meter. Horizontal distance. And what we want to find? What we want to find? To find U equal to how much? Just check. It is equal to 2 meter. R is equal to 3 meter. And U is equal to how much? That we want to find. बघा बरं सोडवता येईल. We know. काय माहिती आपल्याला? दोन फॉर्म्युला माहित आहेत. कुठले कुठले? H is equal to कुठला? H is equal to
GT
half
square.
half GT square आणि दुसरा कुठला? R is equal to
UT.
याच्यामधलं काय फाइंड आउट करायचं आहे? U.
U.
सारखंच परत अजून. If we want to find U from second formula, whether we are knowing T, we don't know T. So again, it is necessary to find T so that we can use second formula. Because in second formula, R is known, U we want to find, but T is not known. So that's why it is necessary to find T first. Hence, H is equal to 1/2 GT square. 1/2 GT square. Therefore, H is known to equal to 1/2 into 9.81 into T square from this value of T. Calculate value of T. Who will tell value of T? After long time, 27. Is it possible for you to tell? Roll number 27. What? Rohan, 37.
Yes, sir.
Is it possible for you to calculate value of T?
Yes, sir. 0.63 second. 63 second.
बरोबर आहे. 4.70. किती म्हणताय? काय टी टी विचारतोय मी. तुम्ही काय सांगताय? Velocity. Okay. T we have calculated. T we have calculated. Now R is equal to UT. Therefore, U is equal to R divided by T. That is equal to how much R we know? 3 divided by T, 0.63. Therefore, E is equal to how much?
4.70.
4.70.
Yes, sir.
76 76.
76.
हा
76.
4.76.
कोणतं वेगळं सांगायला लागलं काय? 76, 69 किती एक्झॅक्ट?
सर 4.76 येतंय.
4.76 येते सर.
ओके 4 पॉईंट आहे ना काहीतरी समथिंग मीटर पर सेकंड. This what will happen if this with this velocity, if that person will jump, then he will reach to at point B, no? If less than this, he is going to drop into, or we can say fall into that. Minimum paise hota actually, minimum velocity, this much he should jump. If he is going to jump with maximum than this, no issue. He will go to next, nothing else. Okay. Type number 1. हे झालंय ना तुम्हाला प्रोजेक्टाइल मोशन? सगळ्यांना झालंय का थोड्या जणांना झालंय? काय काय जणांना झालं नाही? नाही तुम्हाला नाही का झालं? काय काय मध्ये कोण कोण आहे? नाही झालं. तुम्ही कुठं होता? नाही नाही म्हणजे काय म्हणायचं JEE CET कशात होता? CET तुम्ही कशात होता ओंकार? मग कश कोणाला असतं हे? 12th ला. Whatever it may be, forget it. Next, if you are logged in from the mobile, second type of motion which we are going to see. Second type. So here we are not going to see actual, we can say projectile motion. Actual. So first one was simpler. From the certain height with horizontal velocity. We have seen. But here actual motion from the ground. Object will be thrown with certain angle theta with the horizontal with initial velocity u. Are you getting? So here it will at all, this one is more little we can see important. Here u is initial velocity, theta angle with horizontal, then here maximum height h, range r, horizontal range. So this just you can remember the terms whatever it is there. So actually from the ground level we can say object is thrown. Okay, so not necessary to write. If you are logged in the mobile, you can take screenshot, or you can just draw what is we can say trajectory. How that object is going to have a path. Okay, the object ekada throw kela, then how it will have a path. ह्याच्यामधल्या वेगवेगळ्या term. Now we are not going for we can say derivation. I mean, in 12th, have you gone for derivations? Maybe in your 12th, derivations. If you might have known the gone for derivation, here we will see formula direct. Formulas बघणार आहे direct. काय काय होण्याचं वेगळं पण why to go in trouble unnecessary. Many more derivations are there. Equation of trajectory, total time of flight, horizontal range. 2-3 तास लागतील याला सगळं. Anyhow it is not that way, it is not important as well. You can see. I don't know. त्याच्यामध्ये काय कसा केलेला आहे तुम्हाला माहिती आहे का ते आता बेसिक मध्ये जावं लागेल. What is the equation of x axis? What is the equation of y equal to 0 or आता त्याच्यामध्ये म्हणजे ते I don't know is it over or not. नेक्स्ट सेमिस्टर तुम्हाला M2 मध्ये M2 मध्ये M2 म्हणजे मॅथमॅटिक्स 2 मध्ये ट्रेसिंग ऑफ कर्व म्हणून एक सब्जेक्ट आहे, एक चॅप्टर आहे ट्रेसिंग ऑफ कर्व. देयर यू विल फाइंड मेनी मोर थिंग्स रिलेटेड टू कर्व. इट इज अ टाइप ऑफ कर्व ट्रेसिंग. एक कर्व आहे ना तो ऑब्जेक्ट टाकल्यापासून इथपर्यंत येईपर्यंत. सो समथिंग लाईक दिट. सो यू कॅन फाइंड द इक्वेशन ऑफ दॅट कर्व. That's why I have asked what is the equation of x-axis, what is the equation of y-axis. Y-axis equation will be x is equal to 0 and this will be y equal to 0 simply. असं का? Why it is so? इक्वेशन ऑफ x इज इक्वल टू y इक्वल टू 0 इज इक्वेशन ऑफ x ऍक्सिस असं का? का? नाही तसं नाही सर. इन शॉर्ट याचं आन्सर काय आहे? वाय द इक्वेशन ऑफ x इज इक्वल y इज इक्वल टू 0. y x ऍक्सिस वरच्या प्रत्येक पॉइंटचा y कोऑर्डिनेट हा 0 असतो. सिंपल. That's why this is. Similarly, whatever or path is traced by this object, and suppose at any instant it will take point x and y. त्याच्यासाठी इक्वेशन डिराइव्ह करावं लागतं आपल्याला. That is called as equation of trajectory. फार लेंदी होतं हे. That's why let us see whether you are knowing one more thing related to this projectile motion. When it will get, when would we have maximum range or maximum height? म्हणजे इथून तुम्ही ऑब्जेक्ट प्रोजेक्टाईल करताय किंवा थ्रो करताय, किती अँगल मधून टाकल्यानंतर तो मॅक्सिमम हाईटला जाऊ शकतो किंवा इकडे जाऊ शकतो. रेंज, मॅक्सिमम रेंज म्हणूया आपण. रेंज कधी असतो? थिटा इक्वल टू ज्यावेळी 45, त्याचं पण एक डेरिव्हेशन आहे परत, हाऊ इट इज. मग एखादा डेरिव्हेटिव्ह इक्वल टू 0 करायचं आणि वी हॅव टू फाइंड व्हॅल्यू ऑफ थिटा. This also you remember, it may be used, asked maybe in exam. So for what angle you will get maximum range? Theta is equal to 45. If we are going to throw the object through 45, we will get maximum range. So many more things are there. So before, how it comes, I have not kept here. So for that only I have kept equations. So equation of trajectory. Trajectory means what? Sorry. Trajectory means what? Path traced by object once it is going to fall on the ground. Trajectory, the equation of x tan theta minus bx square divided by 2u square cos square theta. If you have logged from the mobile, you can take screenshot. Otherwise, you can write. Actually, I have said parameters. Instead of parameters, you can say equations in projectile motion. ही इक्वेशन आहेत, हे लक्षात ठेवा. टोटल टाइम ऑफ फ्लाइट इन केस ऑफ हॉरिझॉन्टल मोशन काय होता आपला? एच इज इक्वल टू 1/2 GT स्क्वेअर. इथं काय आहे? 2u sin theta. Just you can remember important equation I have noted down here. You can also remember this. Don't go for derivation as well. Only 4 important equations. One more is here. What will be the maximum range? Here, horizontal range. Instead of that, I will say what will be the maximum range. Q square upon G. Because once we are going to put theta equal to 485, sin 90 is how much? Sin 90? 1. So it will be Q square upon G. Since theta equal to 485. Since theta equal to 485. हा यू यू यूच असेल. यू आहे यू स्क्वेअर. How many formulas are there? So equation of trajectory we don't need. पहिले इक्वेशन आपल्याला कधी लागत नाही. इक्वेशन ऑफ ट्रॅजेक्टरी. त्याच्यामधले टर्म बघा लक्षात येतात का? एक्स काय असेल हो? एक्स मग असे पॉइंट दाखवला होता बघा ट्रॅजेक्टरी वरती. at any instant of time. Like say in our case we can take r. आपल्या केस मध्ये r घ्या, मी एक पॉइंट दाखवलाय बघा pxy. त्या पॉइंटचा हॉरिझॉन्टल काय म्हणू आपण x coordinate at any instant of time, or once object is going to fall on the earth, horizontally तो किती लांब जाणार आहे त्याला काय म्हणतोय आपण, रेंज. इन दॅट केस इट विल बी r. ज्यावेळी तो ऑब्जेक्ट ग्राउंडला टच होईल त्यावेळी काय असेल, तो r असेल. और इफ इट इज इन एअर, हवेतच आहे अजून समजा, त्यावेळी काय करायचं, त्याचा एक्स कॉर्डिनेट घ्यायचा, असं म्हणते ते इक्वेशन. Forget about it. Theta, what is theta? Angle made by projectile म्हणूया, with whom? Horizontal. G we know, x u is initial velocity. Any other term? No, all are these terms only. याच टर्म आहेत सगळ्या, विशेष नाही. तर हॉरिझॉन्टल रेंजचा फॉर्म्युला असा येतो, u स्क्वेअर sin 2 theta divided by g. And just now we have discussed when that projectile will be having maximum range when theta equal to, त्याला ही डेरिवेशन आहे. पण आता लक्षात ठेवा की एखादे ऑब्जेक्ट जर आपण थ्रो केलं इनक्लाइंड, तर ते मॅक्सिमम किती कधी जातं, ते 45 हे विचारलं जाऊ शकतं बरं का या MCQ ला. So being a civil, आता actually related to civils आहे, forget about it. We know, we must know this. Okay, we will see one of the problem. Let us see, is it possible to solve? Can we go next? Have you taken this? Only these formulas you remember. आपण टाइप नंबर 3 आणि 4 बघणारच नाहीत, टू अवॉइड द कन्फ्युजन अगेन. कसला ब्रॅकेट म्हणतात त्याला, एवढंच INT म्हणतो मी. कसला म्हणायचं, कसला ब्रॅकेट म्हणायचं, कर्ली म्हणतो, तुम्हाला पण लक्षात येईल. इकडे पण म्हणू का INT, एवढंच लक्षात ठेवा. हार्डली one or two question may come on this. That is to be again here. त्याच्यामध्ये पण इथंच विचारला जाऊ शकतो. इफ नॉट इट मे नॉट बी. इक्वेशन ऑफ ट्रॅजेक्टरी बघून लगेच थोडस नको वाटेल हे असलं काय आहे, एक्स टॅन थिटा मायनस dx स्क्वेअर डिवाइड बाय 2u स्क्वेअर cos स्क्वेअर थिटा. So that's why I told only you should remember this much. Okay, let us see one of the problem. Is it possible to solve? टर्म लक्षात आलं सगळ्या. x म्हणजे, forget about it. One of the point we have considered on the trajectory, and then its x coordinate, theta, angle through which we have projected, g acceleration due to gravity, u is initial velocity. Okay, all are same terms then. Let us see one problem. Is it possible to solve? Before writing, let me know the terms. तुम्हाला टर्म लक्षात येतात का बघा, काय म्हटलं. A particle is projected in air with uniform, इथं हॉरिझॉन्टली वगैरे कुठं शब्द दिसतोय का? A particle is projected horizontally म्हटलं असतं तर आपण फर्स्ट टाइप मध्ये गेलो. But is it told something like this? काहीच म्हटलेलं नाही. Let us read first. A particle is projected in air with uniform velocity 80 meter per second at an angle of 45 degree with the horizontal. Find horizontal range, maximum height attained by the particle, and time of flight. Three things we are necessary to find. Just check, read the problem. When particle is projected in the air, there is no word horizontally, so we should not go into type number 1. So we should think about type number 2. Okay, so which things are given here? Can someone tell me here which things are given? Uniform velocity. What is that velocity? What notation we are going to give? काय म्हणतोय आपण त्याला? समजते का नाही? अँगल ला काय नोटेशन दिलंय आपण? विथ हॉरिझॉन्टल थीटा. Theta, and how much it is? 45. Okay, here I will write to find what it is necessary to find.
Range.
Horizontal range. or I will say range. Okay, range here horizontal. R equal to how much? Second, maximum height. H max म्हणतो. H max. How much it is?
And time.
Third one,
Time of flight.
time of flight T. Time of flight. T. Okay. For projectile motion or projectile projected inclined म्हणता येईल बघा. प्रोजेक्ट झालं काय फॉर प्रोजेक्टाईल for projectile we know projected inclined म्हणतो projected inclined projected inclined we know कुठले कुठले फॉर्म्युला माहित आहे तो आपल्याला we know equations of linear motion something like that आपल्याला जेवढे माहित तेवढे इक्वेशन लिहायचे कुठले कुठले आहेत सांगा पहिलं which we should use that is our secondary part but which we know that we will write first roll number 1 ना किती सांगा बरं इक्वेशन फास्ट लिहिलेत ना नोटबुक मध्ये हा हा ओके टी is equal to how much 2u sin theta divided by g. Okay, second equation r is equal to u square sin 2 theta okay next h is equal to u square h is stands for height no height साठी h सांगा h चं काय u square sin square theta okay u square sin square theta divided by 2g. Okay, any more anything is more or only 3 equations are there okay now you will think now from the given and from what we know or what we want to find we know initial velocity we know theta can we find time directly time of flight directly we can find no that's why in case of dynamics it's better to write equations irrespective of which you are going to use and which you are not going to use लेस काय होत नाही कुठलं इक्वेशन आपल्याला कुठलं पाहिजे आणि कुठलं नाही याचा विचारच करायचा नाही तिन्ही लिहून घ्यायचे ऑनलाईन स्टुडंट्स आर यू विथ मी
Yes, sir.
Yes, sir.
you are online only okay so which equation we should here use to find time of flight to find t t is equal to 2u sin theta divided by g that is equal to 2 into u 80 into sin 45 तुमचं आहे का 5-10 मिनिट 5 मिनिट नाहीच ना 5 मिनिट First, T is equal to
11.53.
11.53.
ha
11.53.
11 point
53.
11.53. Okay, 11.53. Next, which मिळाला range. Range also you can find directly, no? U is knowing, theta is known, G is also known. You can find directly. To find R equal to U is also known. U is known, I think 80 square sine 90 means 1 and G. Just check how much. And H max also you can find. Why it is a word used to H max? Anybody? What the height का विचार? Is whatever height we are going to get, it is maximum. To find H max equal to U square sin square theta divided by 2G. Calculate करा fast सांगा हे आन्सर किती आहे? R. How much online? Anyone? From online? तुमचे किती आहे सांगा?
652.
652.
652.39.
139. तुमचे किती आहे? 06. Okay. Somebody saying 652.39 something. It's okay. Not we cannot call it as a wrong. Don't worry. 652 somebody told. Point something. Who was telling? 39.
39.
Yes, sir.
Okay, no issue. Your is also correct. We can see almost point. Don't worry. And H max? How much? 163.09 meter. So these will be answers. Very simple. If you know formula, just you have to keep the values, nothing else. You can put directly values. It max 1/4 येते काय म्हणता? हा म्हणजे येते का मग 653.39 असा फॉर्म्युला काय? गुड. You can note here then. Okay, good point. I don't know this. काय म्हणू? If theta equal to 45, then H max ना? H max or H? Okay. झालं मॅडम 2 मिनिट. H max or H लिहू R by 4. If theta is equal to 45, then H is equal to R by 4. Please note down this remaining. Or shall I give one problem? एक देऊ का?
Yes, sir.
Yes, sir.
नको म्हटलं तर देणार, हो म्हटलं नाही म्हटलं तर नाही देणार. कसं करायचं? Shall I give one? Okay, one problem. Just note down. If possible, take screenshot so that this chapter will get over with this last. You can take screenshot. Try to solve. If not, we will solve. Don't worry. Get la? Have you taken?
Yes, sir.
Yes, sir.
Okay. Thank you for joining the lecture.